We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
From NASA's SOHO observatory came another anomaly. Footage of a disc-shaped structure hovering beside the sun. Silent, perfectly geometric, vast beyond comprehension. Astronomers already call 3I/ATLAS massive, its scale almost beyond belief.
You're looking at a piece of what would have become a planet in another star system.
But compared to this disk, even Atlas looks small. If the claims are true, then the structure is 100 times larger, and nothing in our science can explain it. Our place beside the sun. The image is simple, yet overwhelming. A bright ball of fire dominates the frame, its surface alive with turbulence, arcs of plasma, and storms that rage on scales impossible to imagine. Earth feels vast when viewed from its surface. Yet, in the cosmic scale of things, Earth is little more than dust. The Sun, by comparison, is so massive that over 1 million Earths could fit inside it. It is easy to forget this balance because the Sun is so constant, but when we zoom out, when Earth is shown as a fragile speck beside that fiery giant, we are reminded of just how small we truly are. That is why images from the Solar and Heliospheric Observatory, better known as SOHO, matter so much. Launched in 1995, as a joint project between NASA and the European Space Agency, SOHO was designed with a clear practical mission: to monitor solar activity. The Sun is a volatile star, constantly throwing off eruptions of plasma and radiation. When these eruptions, called solar flares or coronal mass ejections, are aimed toward Earth, they can cause blackouts, disrupt satellites, and even endanger astronauts. SOHO's primary purpose has always been to study these outbursts and give scientists enough warning to protect our technology. For decades, it has done exactly that. Thanks to its instruments, scientists have built models of solar wind, tracked storms, and learned how to prepare for sudden bursts of radiation that can ripple through the solar system. In the background of its data, beyond the expected patterns of solar flares and plasma loops, SOHO has captured things that should not be there. These images were never the observatory's intended purpose, but once they emerged, they were impossible to ignore. At first, many dismissed them as camera glitches or errors in data transmission. But the consistency of these appearances across different instruments and over different years makes such dismissals harder to maintain. Within SOHO's images, structures appear that rival or exceed the size of planets themselves. And one of those mysteries, and perhaps the most striking of them all, is a disc-shaped structure that seems to move with precision, emerging suddenly as if revealed by the very light it tries to hide against. Could it be an illusion? Or have we, through the constant watch of a solar observatory, stumbled onto evidence of something vast beyond imagination? The object itself. What makes the object so striking is not only its presence, but its precision. Nothing about the solar environment is ever neat or orderly, and yet here is a shape that defies that law. A perfect circle, sharp lines, a geometry that looks designed, almost mechanical. It does not blend into the sun's chaos. It stands out from it, like an engineered structure superimposed on a storm. The structure seems to reveal itself in an instant. Some theorists argue that a solar flare may have interfered with some kind of concealment technology, briefly making the object visible before it vanished again. Others suggest the possibility that it did not cloak at all, but arrived deliberately at that exact moment, emerging into position near the sun. Whatever the cause, the suddenness of its appearance has fueled endless debate. A comet can be tracked. An asteroid can be calculated. But an object that manifests without warning and with a shape so symmetrical, forces a different kind of question. What makes the mystery even deeper is the object's persistence. It is not a fleeting flare or a trick of light. It does not crumble under the sun's fury. Against forces that no human technology could endure for even a fraction of a second, this object holds steady, calm, deliberate. It is this endurance that convinces many that the structure is not natural. Plasma formations may be vast, but they are chaotic. They twist, distort, and dissipate. This object does not. Its edges remain smooth, its outline sharp, its presence unyielding. For some observers, this is the strongest evidence of all. If it were natural, it would bend to the sun's violence. But it remains as if designed for this very environment. The specific sequence that drew attention was recorded on March 27, 2023, by SOHO's LASCO C2 coronagraph, an instrument built to block out the sun's glare and capture faint objects around it. In that frame, the disk-shaped anomaly appeared at heliographic coordinates 05 degrees north, 112 degrees west, lingering for several frames before fading. NASA's public archive still lists the data sequence, though the anomaly itself has never been officially addressed in mission reports. A theory imagines the object as an energy-harvesting platform. The sun is the ultimate power source, a furnace releasing more energy in a single second than humanity has consumed in all of history. For a civilization advanced enough to endure its environment, the sun would be the perfect place to draw power. A colossal station could collect energy directly from its radiation, storing or transmitting it across space. If true, then what SOHO captured is not a random anomaly, but a megastructure designed for the most ambitious purpose imaginable: to tap the heart of a star. Others suggest a different role altogether. Instead of harvesting, it could be observing. A monitoring station positioned at the very center of the solar system, able to watch not just the sun, but Earth and the inner planets as well. The vantage point would be unparalleled, a fixed post from which every orbit could be tracked, every planetary alignment observed. From this perspective, the sun itself becomes less a source of danger and more a shield, a curtain of blinding radiation behind which an advanced structure could quietly operate, unseen except in moments of accidental revelation. Astrophysicist Dr. Harold Geller, speaking on anomalies in SOHO data, once remarked, "Artifacts are common, but when a structure maintains symmetry across multiple frames, we must at least acknowledge the possibility of something beyond glitches." While he did not comment directly on this disk, his caution has fueled speculation that NASA scientists know more than they publish. None of these theories can be proven, but each begins with the same foundation. What we see in SOHO's images is not something human. No spacecraft we have ever built could withstand the heat, the radiation, or the gravity of that environment. Yet this object not only endures, it holds its place, unmoved by storms that could swallow worlds. If something that massive, that deliberate, can reveal itself beside the sun, what else might already be hiding in plain sight? 3I/ATLAS as the scientific benchmark. When talking about massive structures in space, it helps to anchor the imagination with what science has already confirmed. And in 2025, astronomers gained their third clear example of an interstellar visitor, 3I/ATLAS. Unlike the strange disc-shaped forms captured near the sun, this object has been tracked, measured, and catalogued in detail. And the numbers alone show just how enormous an interstellar wanderer can be. This is not just another comet. It is only the third interstellar object ever confirmed in human history, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Each discovery reshaped astronomy, and 3E/ATLAS may be the most extraordinary of them all. Right now, 3I/ATLAS is traveling at around 58 kilometers per second. As it approaches its closest pass by the Sun, its perihelion on October 29, 2025, that speed will rise to roughly 68 kilometers per second. For context, Mercury, the fastest planet in our solar system because of its tight orbit around the Sun, only manages about 47 kilometers per second. This means 3I/ATLAS is moving faster than any planet bound to our star. It is not tethered by solar gravity in the same way as it is passing through. Size is where the true scale begins to reveal itself. The solid core, or nucleus, is estimated to be between 46 and 50 kilometers in diameter. That's already larger than most comets humanity has ever tracked. For comparison, Halley's Comet has a nucleus only about 11 kilometers across. But beyond the nucleus lies the coma, the great envelope of gas, dust, and plasma that surrounds such a body when it nears a star. In optical light, the coma of 3I/ATLAS measures around 25,000 kilometers wide, about twice the diameter of Earth. That is staggering enough, but it is only the beginning. When measured in near-infrared, the true extent of its carbon dioxide coma is revealed, roughly 700,000 kilometers across. That is half the diameter of the Sun itself. To picture it, imagine Earth vanishing inside this envelope 1,000 times over. That is the level of scale we are dealing with. The chemistry of 3I/ATLAS is another puzzle. Spectral analysis shows that it is unusually rich in carbon dioxide, far more so than most comets ever observed. Unlike comets that formed within our solar system, 3I/ATLAS was created in a completely different stellar nursery. It has spent eons traveling across the void, bombarded by cosmic rays, and shaped by environments no Earth-based model can perfectly explain. Which is why astronomers warn against applying standard comet physics to it. This is not just another icy body set free from the Kuiper belt. This is something that carries the chemical fingerprint of another star system. Its path adds another layer of intrigue. 3I/ATLAS is traveling on a retrograde orbit, tilted 175 degrees against the planets. In other words, it is flying backwards against the flow of the entire solar system, slicing across the plane of the planets like a cosmic blade, moving upstream against the current. That strangeness alone sets it apart from almost every object we've ever studied. In practice, this means it is moving almost directly opposite to the general motion of our solar system, cutting across the ecliptic plane at a shallow angle. That closeness to the plane of the planets is unusual. It means the object is not just skimming through, but interacting with the same regions of the solar wind and heliospheric current sheet that tie all the planets together in an electromagnetic web. In other words, 3I/ATLAS is not a visitor passing in the far outer reaches. It is slicing through the very zones of plasma and solar radiation that we inhabit. And it will be doing so for a long stretch of time. Researchers are already studying its electromagnetic behavior. That enormous carbon dioxide coma is not inert. It is active, ionized by the Sun's ultraviolet and X-ray radiation, and alive with plasma interactions. In laboratory experiments, carbon-rich plasmas produce unusual effects. Nanoparticles of graphite, and even microscopic diamonds forming under charged conditions. Now imagine such processes scaled up across a coma half the width of the Sun. The result is a body that behaves unlike any comet we have ever observed, both chemically and electrically. All of this makes 3I/ATLAS the perfect benchmark for scale. If a natural object from beyond our system can grow a coma that stretches across half the Sun, then the claim of something even larger near our star suddenly becomes easier to imagine. This is why the comparisons matter. A disk-shaped anomaly captured by SOHO, appearing stable against solar fury, could be judged in light of what science already accepts. If a carbon-rich traveler can cloak itself in a veil hundreds of thousands of kilometers wide, what might be possible for something engineered? The disk beside the Sun is said to be 100 times larger than 3i/ATLAS. Even if that claim is exaggerated, the benchmark is still set. A natural interstellar object, massive in its own right, gives us scale to measure against. And the mystery object near the Sun, mechanical in appearance and resistant to solar forces, stands outside those natural boundaries. The benchmark has been set, and it raises the unavoidable question: if 3i/ATLAS is natural and this colossal, what do we call something that looks designed, larger still, and filmed beside the Sun itself? The size comparison: disk versus 3i/ATLAS. If 3i/ATLAS shows us what nature can build, then the disk-shaped object beside the Sun feels like something else entirely. By every measure, the SOHO anomaly makes even this colossal interstellar traveler look small. That's why so many have latched onto the claim that it could be 100 times larger. Picture the comparison. 3i/ATLAS has a solid core about 46 to 50 kilometers wide. Around it, a glowing coma stretches 25,000 kilometers in visible light, already twice Earth's diameter. Push into the near-infrared, and the carbon dioxide envelope balloons to 700,000 kilometers, nearly half the Sun's width, a staggering natural giant. Now, place that next to SOHO's footage. The disk doesn't glow with haze. It doesn't scatter like dust. It cuts clean into the chaos, a sharp silhouette against solar fire. Where Atlas looks messy and ever-changing, this anomaly looks precise, geometric, built. The scale is what stops people cold. 1,000,000 Earths could fit inside the Sun. And yet, this disk appears big enough to show up clearly against that star's burning edge. Even conservative views make it larger than Earth, and in some readings, larger still than ATLAS's sprawling coma. That's where the 100 times bigger idea takes hold, not from measured data, but from the raw visual shock of its size beside the Sun. Endurance deepens the mystery. Atlas is a body breaking down under heat, boiling away into its giant cloud. The disk, by contrast, shows no signs of erosion. It does not fade. It does not scatter. It holds steady against radiation and winds that should tear any material apart. That is why the two objects feel like they come from different categories. Atlas is natural. The disk looks engineered. Skeptics call it a camera glitch, an artifact of the instruments. But that fails to explain the clean symmetry, the way it appears across frames, or why it resembles the disk form linked to craft in UFO accounts for decades. If it is just noise, why that shape? Why that persistence? And this is what makes the comparison unsettling. If astronomers are right, that Atlas is extraordinary, a natural body half the Sun's width, then what do we make of something that looks equal in size, sharper in form, and tougher than any comet could ever be? For many, the answer is simple. The Sun object is not a passing anomaly at all. It's a station, maybe parked there deliberately. And if it is, the real question isn't what it is, it's what it's doing beside our star. Implications and theories. If the disk-shaped object beside the Sun is real, then its very existence forces us into uncharted territory. Theories about comets, rogue planets, or brown dwarfs can only take us so far. This is something else. A structure of this scale, holding steady in one of the most hostile environments in the known universe, would suggest a level of technology billions of years ahead of our own. The gulf between what humanity can build and what this object appears to represent is not measured in decades or centuries, but in entire civilizational ages. Consider the possibilities that such a structure implies. The most common theory is energy harvesting. The sun is the largest and most reliable power source in our system, producing more energy in 1 second than humanity has consumed in all of history. If an advanced civilization had the ability to construct vast platforms or stations in close orbit, the sun could provide nearly limitless power. The disk may not be a ship at all, but a collector, siphoning energy directly from the solar atmosphere, storing it or transmitting it across space in ways we cannot yet imagine. Others suggest the object could function as a monitoring station. From its vantage point beside the sun, it would have the perfect line of sight over the inner solar system, Earth included. If its role is observation, then its sudden appearance in SOHO imagery could have been a rare slip, the result of cloaking technology disrupted by a solar flare or coronal outburst. That possibility carries a darker edge. If it is watching, then it has likely been watching for a long time, hidden from sight until conditions exposed it briefly. A third theory takes the discussion even further: the sun as a hub, a natural launch point for interstellar travel. The gravitational pull of the star, combined with its immense energy output, could provide the perfect platform for civilizations capable of manipulating physics far beyond our current reach. By positioning stations or gateways near the sun, such civilizations could harness its energy for propulsion, opening pathways across the galaxy. The disk might not simply be a collector or a monitor. It could be part of a larger system that turns our star into a cosmic springboard. Yet, if the implications are this enormous, why the secrecy? Why is it that the footage circulates among amateur astronomers and independent researchers, but rarely receives acknowledgement from space agencies or governments? The silence may not be accidental. There are many possible reasons why officials would choose not to confirm or even seriously investigate what these images suggest. One explanation is fear of panic. Humanity has always sought comfort in the idea that we are central, unique, and in control of our world. To admit that colossal engineered structures exist near our sun, structures that dwarf our planet and laugh at our technology, would shatter that worldview overnight. For some, it would spark awe and curiosity. For others, it would provoke dread, helplessness, and a sense that humanity is nothing more than a fragile bystander in a universe already occupied. Officials may believe that most of the public is not prepared to face such a revelation. Another factor is religion and philosophy. For millennia, cultures have built belief systems around the notion that humanity holds a special place in creation. To admit that vastly superior intelligences exist and are operating openly in our skies would challenge the foundations of those traditions. Faith leaders might struggle to reconcile such revelations with established doctrine, while billions could experience crises of belief. There is also the simple fact of vulnerability. If governments admitted they do not understand these anomalies and have no means of addressing them, then their limitations would be exposed. It is far easier to ignore or dismiss the evidence than to face the uncomfortable reality of helplessness in the face of something greater. And yet, secrecy rarely exists in a vacuum. Across multiple platforms and events, a pattern emerges. The SOHO images reveal structured forms near the sun. Amateur astronomers report strange lights skimming the moon. SpaceX missions capture anomalies in the background of their launches, dismissed as debris or artifacts. Each incident on its own could be brushed away. But together, they suggest something more troubling: a consistent effort to conceal, distract, or remain silent about anomalies that refuse to fit within accepted explanations. This pattern does not prove intent, but it does raise suspicion. If the anomalies are meaningless, why censor them? If they are harmless, why remove them? The silence itself becomes evidence, pointing toward the possibility that there is something real to hide, something vast, active, and present in our cosmic neighborhood. Whatever the truth, the implications are staggering. To accept that these structures exist is to accept that humanity is no longer alone and never has been. What do we know? So is this new interstellar object really 100 times larger than 3I/ATLAS? For now, no one can say for sure. What we do have is the evidence of something vast and structured operating beside our sun. Why now? Why here? Is it a test? Or simply a presence so far beyond us that our findings don't matter? Its very appearance leaves no doubt. The universe is still hiding secrets powerful enough to rewrite everything we think we know.